Hello friends, how are you? I hope you are well. A new day, a new beginning. Today's topic is regarding triple point. It is a part of thermal properties of matter. Before reaching at the triple point, we have to go through three different phases of matter. So let us start with change of phase. Change of phase or state. Normally, a matter can exist in three different states. What are the three different states? Solid state, liquid state, and gaseous state. Normally, we find solid, liquid, and gaseous state, or you can say that vapor states. How it is possible? A matter can exist in different states depending upon its temperature and pressure. For example, ice is there. Its temperature is 0 degree centigrade. You supplied heat. It became water. Again you supplied heat. It became water vapor. So, due to heat, ice became water. When you supply more heat, one stage comes when water converts into vapor. That means I can say that ice can exist in three different states. Here I did not change the pressure. At the same pressure, a substance also can exist in three different states. It is possible due to transfer, or you can say due to exchange of heat. Then what do you mean by change of phase? The process of the change of a substance. The process of change of a substance from one phase to another at a constant temperature is called change of phase or change of state. For example, you see that we have taken the ice. We are supplying heat. After that, we are getting water. At the same time, if you continue to supply the heat, one stage comes where we get the vapor. At the same time, if you cool it, again we get back the ice. That process what we call freezing. When you supply the heat, ice became water. That means ice absorbed the heat. That process we say melting. During the melting, there will be absorption of heat energy. And during the freezing, there will be liberation of heat energy. Now, water, when you supply heat, one stage comes, the water convert into gaseous state or the vapor. That process we say boiling. At the same time, the vapor or the gaseous state, if we cool it, again we will get back the water in this case. That process we say condensation. So, during the melting, heat is absorbed. During the freezing, heat is ejected. During the boiling, heat is absorbed. During the condensation, heat is released. Except that matter can directly convert from solid state to vapor state or gaseous state, or we can say that from gaseous state to directly it can convert into solid state. So conversion from solid state to gaseous state directly we say that is the sublimation. Whereas changing from gaseous state to solid state, that is called solidification. So, matter can change in different states depending upon its temperature and pressure. Now, let us discuss about these 2 points, melting and boiling. So, at first, I would like to explain what is melting and fusion also. Melting and fusion. Listen carefully. Suppose in a beaker you have taken some ice cubes. You can place it on a tripod with the help of the spirit lamp. You supply the heat. Before heating, you can note down its temperature. So this is ice. So temperature definitely either will be 0 or less than 0 degrees Celsius. With the help of thermometer, you can change its temperature. So you can supply the heat from a constant source of heat, and at the same time you have to note down the temperature at regular intervals. For example, 0 degrees Celsius temperature is there. Now you started supplying heat. Time to time you have to note down the temperature. Now time is 0 second. Starting, you found the temperature is 0 degrees Celsius. After 30 seconds, you found that its temperature also 0 degrees Celsius. Okay. Again, after regular interval, you check the temperature. For example, you got it is 0 degrees Celsius. During that time, you observe the container. You will find inside the container when you are supplying the heat, the temperature is not increasing, but ice starts to melt slow and slow. That means inside the container you can find both ice plus water. Again, suppose after 90 seconds you check its temperature. That time its temperature is suppose 1 degree Celsius. That time you will not observe the ice, you will find the water only. Or you can say one stage comes where the 0 degree Celsius but complete water is there. Slow and slow when the temperature increases. Suppose 5 degrees Celsius, 10 degrees Celsius, time increasing 90, 120, 150 seconds I am taking, but temperature started increasing. That time only water you will find. So in the beginning we found that there is no change in temperature. Instead of that, substance is changing from one state to another state. In case of ice, it is converting into water. Where that heat gone? That matter in the next video I shall explain in the form of latent heat. So I can say that heat is utilized here to convert the ice into water. So during the change of state from ice to water, there is no rise in temperature. The fact is that heat what we are supplying, it is utilized to convert the ice into water, to break the bond between the particles present in ice. Okay? So here we found that substance changed from solid to liquid. But during changing time, there is no change in temperature. So I can say that the process is called melting. The process of changing of a solid into liquid. The process of changing a substance from solid to liquid at constant temperature is called melting. See that in case of the ice, it converted into water. At the same time, if we cool the water, again we will get back the ice. So ice to water, I said that is melting. Water to ice, that is we can say freezing. So you remember that the amount of heat absorbed by the ice to convert into water is also equal to amount of heat released by water to convert into ice. How much amount of heat is required to convert ice into water? Same amount of heat energy has to release by the water to convert into ice. So the process of changing of a substance from one state to from solid to liquid at constant temperature is called melting, and the temperature at which it happens, that is called melting point. The temperature at which substance change solid to liquid, the constant temperature is called the melting point. If we take the melting point at a standard pressure, that is called the normal melting point. The melting point at standard pressure, the melting point at standard pressure is called normal melting point. Standard pressure means that is the 1 atmosphere pressure, we say standard pressure. This melting point also affected by certain factors. One factor is the impurities. Impurity is one of the factor that decides the melting point. If impurities increases, the melting point decreases. Now you see that suppose the melting point of ice equal to 0 degrees Celsius at STP. Sorry, melting point of ice is 0 degrees Celsius at standard atmospheric pressure. In this ice, if a proper amount of salt is added, the melting point will decrease to minus 22 degree Celsius. Listen carefully. The ice melt at 0 degree Celsius. After adding certain amount of salt, in a proper amount of salt it can be added, its melting point goes to minus 22 degrees Celsius. You might have observed that in your home, in your day-to-day life, fish market, with the ice pieces, sometimes they add the salt because they want to decrease the melting point of ice into minus 22 degree Celsius. That means the ice easily will not melt. Okay? So by increasing the impurities, we can increasing the melting point. But what about the pressure? What is the effect of pressure on melting point? Listen carefully. Suppose in case of ice, when we supply heat, it contracts. The volume of ice more than the volume of water what we have taken. So in case of the substance where it contract on heating, that means if the substance contract on heating, in that case I can say that melting point decreases. Melting point decreases with increase in pressure. Pressure increases but melting point decreases. Means what temperature it should melt? It will melt less than that temperature. One example I shall give. So I said that if the substance contract on heating, melting point increases with increasing. So melting point decreases. Substance contract on heating, melting point decreases with increase in pressure. Let us see an example how melting point is decreasing with increase in pressure. Suppose this is an ice cube. You have placed on the help of a supporter. This is a ice cube. Okay? Now you take one thin wire. That wire you hang it here with the help of a certain weight. Very thin wire you have taken but strong. You have applied certain weight. That means it is applying some pressure on the ice. Slow and slow you will observe that the thin wire is coming down. How? Because there is an increase in pressure. Where the thread is there, where we are applying the weight, means we are applying force. Force per area is the pressure. So due to increase in pressure, the ice starts to melt because pressure increases, melting point decreases. In what temperature? It was not melting. In the same temperature, it started melting. That is due to decrease in its melting point. At the same time, when the thread will pass just backside, again you will find the water became freeze because their pressure decreased. When the pressure decreased, melting point that time increased. That means which one became water, again it became ice. Okay? So the phenomenon of refreezing, the water again became freeze. There is ice, Due to pressure it became water. Again once again the water became freeze. So the phenomenon of refreezing is called regulation. The phenomenon of refreezing is called regulation. What I found in case of the skating, the person who is playing the skating, when he is standing under his feet, pressure is increasing, ice is easily melting because its melting point is decreasing. At the same time, he moves smoothly because the water behaves like a lubricant, so it helps him for skating purposes. So this is the phenomenon of refreezing is called regulation. Let us see about the heating curve of ice during melting. Heating curve of ice during melting. Now we will take a graph between time and temperature. Suppose time we are taking in second, temperature in a degree Celsius. Okay? If you draw the graph will be, for example, here I have taken 30 second, 60 second, 90 second, 120 second, 150 second, 180 second. Here I have taken the 10 degree, 20 degree, 30 degree, 40 degree. Suppose the ice we have taken 0 degree Celsius temperature. Whenever we supply the heat, suddenly its temperature not increasing, just I said, because that time ice converting into water. That means we can get ice and water. For example, 140 degree Celsius temperature, it started to increase its temperature. That means up to 0 to 120 degree Celsius, its temperature is not changing. During that time, we can find here ice plus water. Once the temperature started increasing, means it started boiling. Once it started increasing more than 0 degree, that means we are moving. So once we reach at the temperature more than 0 degree Celsius, that means we will find only water. Now we will find the water. Suppose 40 degree Celsius, we will find only water. So between 0 to 120 second, only we will find change in state, not change in temperature. That means we will find ice plus water. Once it completely converted into water, it starts to increase its temperature. So during this time, we will find only water. So this is about the heating curve of ice during melting. Let us discuss about the boiling. Vaporization, or I can say that boiling. So children, once ice convert into water, it converted into water. Suppose the water temperature reaches at 100 degrees Celsius, that means water will start to convert into vapor state, or that is the gaseous state. So whenever water convert into water vapor, during the time you won't find there is change in temperature. For example, in standard pressure, the boiling point of water is 100 degrees Celsius. That means until entire water convert into water vapor, there will be no change in temperature. So I can say that the process of a changing of a liquid into gas at a constant temperature is called boiling. The process of a change of a substance. The process of change of a substance from liquid to vapor at constant temperature is called boiling. The boiling point of water is 100 degree Celsius. Whenever you do practically, definitely you find some error may be there. It may not be exactly 100. Suppose it may be 100.01, because in our home or some ready-made arrangement we have made, there may be some practical error, no doubt, but almost 100 degrees Celsius the water starts to boil. So until entire water convert into water vapor, there will be no change in temperature. So this is about the boiling point of water, or the process is called the boiling. So the temperature at which liquid convert into vapor without changing the temperature, that constant temperature is called the boiling point. So some factors are there which can affect the boiling point. What factor? One is the impurities. One is the impurities. When impurities increases, boiling point also increases. Except that pressure is also one of the factor. If the impurity increases, boiling point increases. What about the pressure? Pressure increases, boiling point also increases. You see that inside the pressure cooker, the pressure is more. Inside the pressure cooker, pressure is 1.7 times more than the normal pressure. So inside the pressure cooker, the boiling point of water ranges between 20 degree to 25 degree Celsius. As a result, the mountaineers, those goes to the higher level where the pressure is low, to counter that they use the what? Pressure cooker. Because inside the pressure cooker, pressure is high. As a result, its a boiling point will be high. And so far as impurity is concerned, sometimes you might have observed, you might have listened that your mother add some salt for boiling the vegetables. What is the reason? The reason is that when you are adding the salt, that means we are increasing the impurities level. As a result, its boiling point is increasing. Instead of getting temperature 100 degree, it is getting more than 100 degrees Celsius temperature. So I can say that pressure and impurities can affect the boiling point. Now you see that, for example, in your NCERT book this example is mentioned. For example, this is a round bottom flask. Okay, it is fitted with a tight cork. Through that cork you enter one thermometer. Okay, another one outlet you can fill for escaping the gas. Suppose you take some water here. Okay, if you start supplying heat, in the beginning what will find, some bubble will come outside. The reason is that some amount of air is already mixed with the water. So whenever you started heat, the air starts to escape in the form of bubbles from the surface of the liquid. From down it will come to the upwards. At the same time, immediately the water which is bottom of the container, it will get the heat, it will convert into steam. Again the bubble will come, but that bubble will come to this cold region just below the top portion, where it will condense. The gas comes in the form of the bubbles, it condenses, which one will disappear. But once the temperature of water reaches that 100 degrees Celsius, the entire mass of water, I am not telling the water which is bottom, which is top or which is middle. If the entire mass of the water reaches that 100 degrees Celsius, that means at that time boiling starts. So the vapor can escape through this way. Vapor can escape through this way. Now let us do one thing. Suppose you remove this one. You close it. Remove the thermometer. You close this container completely. You will find that the boiling stops. Why the boiling stops? Because when I stopped it, pressure inside that increased. Pressure inside that increased. So when the pressure increased, what about the boiling point? Before that boiling point was 100 degree. Now boiling point is not 100 degree. It needs more temperature. So at that time we will find that pressure increase means boiling switch. Boiling stops because now temperature 100 degree. Now it will not boil at 100 degree. It needs more temperature because pressure increased. So we have to supply more heat. At the same time, when I said that you stop supplying heat. If you stop supplying heat and stop here, you will find that boiling process will stop. If the temperature reaches more than 100, then there is a chance of a boiling again will start. But suddenly it will not start because before that 100 degree was there. We stopped, pressure increased. So when the pressure increased, boiling point also increased, or pressure decreasing, boiling point decreases. Now let us see what we'll do. Now you close this container properly. Close this container properly, already closed. Now you can turn it upside down. If you turn it upside down, you pour some ice cold water, very cold water like ice cold water. What will happen? The vapor which is inside that, it will condense. It will condense. So the volume will decrease. That means the pressure will decrease. Okay? That time pressure increased. Now pressure decreased. When pressure decreases, again the water starts boiling. So this is the matter regarding the boiling and melting. I discussed with you melting point, boiling point, but today's our headline is the triple point. Up to now I have not reached there. Okay, let us come to the point, triple point, very important triple point. You might have heard about the Triveni Sangam, the point where, or the place where our three sacred rivers Ganga, Yamuna and Saraswati are joined. So this is the triple point in the thermal behavior of matter. It is different from that. So what is this triple point? I can say that the triple point of a substance is the temperature and pressure at which a substance can coexist in three different states. Listen carefully. It is about the temperature and pressure of the substance. A substance at this temperature and pressure can exist in three different states. I can say that the temperature and pressure at which a substance can coexist in its three different phases is called its triple point. So, how to find that triple point? In fact, it is found experimentally. I will try to explain it through the pressure versus temperature graph. So, a graph between temperature and pressure of a substance is called a graph between temperature and pressure is called phase diagram, or you can say phasor diagram. So, that graph, it divides the, see here, this is the temperature, degree Celsius, this is the pressure in the atmosphere. I have taken in the y-axis, temperature in the x-axis. In fact, the graph will be like this. In this case, the diagram divides the pressure temperature plane into three regions. What are the three regions? One is the solid region, one is the liquid region, one is the vapor region. See here, the curve OB represents OB curve. It represents sublimation. Here, this is solid, this is liquid, this is vapor. Three phases are there. Solid phase is there, liquid phase is there, vapor phase is there. So, the graph BO or OB, it represents sublimation curve. So, once again I shall mention here BO, that is sublimation curve. Here AO, it represents fusion curve. CO represents vaporization curve. Three things are there. Divided into three regions: solid region, liquid region, gaseous region. Any point on the sublimation curve, it represents the state of the substance which convert directly from solid to gaseous state. This point O, it is the common point, or you can say that this is the point where a substance can exist, or you can say it can coexist in three different states, whether solid state, liquid state or gaseous state. This point is called the triple point. So different substances having its different triple point. So in case of the water, or you can say that in case of the ice, its triple point is 273.16 Kelvin. This is about the temperature. What about its pressure? 6.11 into 10 to the power minus 3 Pascal. At this temperature and pressure, water can exist in three different states, that is ice, water and water vapor. I hope that you might have clear regarding the triple point. Children, don't forget to subscribe, comment and share this video. So in the next video we'll discuss about the latent heat. Until then, bye. Thank you.